everyone. Welcome to today's summit, Getting Started with Cloud Security. This event was organized by the hardworking folks at Redmond Magazine and Virtualization and Cloud Review, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, Rubrik, the Zero Trust Data Management Company, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of two information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsor, Rubrik, has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. As you leave the summit today, you'll be asked to take a very short survey. We would greatly appreciate it if you would share your honest opinions. Our editors read every comment, and they help to shape our future events. And last but not least, at the end of the second session, one lucky attendee will be receiving a brand new HP 15.6-inch touchscreen laptop. But you must be present to win, so stick with us. Now let's get started with our first session, Cloud Security 101, Top Enterprise Cloud Setup and Configuration Best Practices. For this session, we've called on Stephen Smiley, AWS Solutions Architect at Intervision Systems. Mr. Smiley leads Intervision's AWS consulting program, where he focuses on enabling innovation by making security fundamentals accessible and actionable instead of a roadblock. A former military intelligence officer, he balances strategic and tactical thinking to help his company's customers accomplish their objectives. You are in for a great session. Take it away, Stephen.
Hey, thanks for having me today, John. I'm excited to be here. It's a topic that I really enjoy, cloud security, especially at the, enterprise level where it's such a challenge. And this is something that I've been focusing on for a number of years now. And so I've seen it across many different cloud providers. I've seen it in different environments from, public sector to private. And I'm hoping to share with you all today some of the, the highlights of that, some of the things I've seen people go wrong with and the things that I think are fundamental to success. I'd like to start today with just a special note on our current environment, because I'm seeing this a lot. As everybody knows, there's a war going on, and the Cybersecurity and Infrastructure Agency has given some guidance saying that there's no specific or credible cyber threats to the U.S., but really everybody should adopt a heightened posture when it comes to cybersecurity, right? We should consider that there's, metaphorical bullets flying in all directions, and we want to make sure that we are protected from those. So CISA's guidance for leaders are these 5 points of, empowering your chief information security officers, lowering reporting thresholds, testing your response plans, focusing on continuity or business continuity, and really planning for the worst. So this is coming from CISA's Shields Up guidance, and that's not specific to cloud. That is just in general. And if you have questions about how you can protect yourself in this environment, that's a great resource. And of course, you can ask me any questions or reach out to me directly if you've got some other questions. So today we're focusing on cloud security. And since we're doing this at the fundamental 101 level, I'm going to keep my eye on the Q&A box. So feel free to send me any questions, and I'll do my best to answer them along the way. Or if I don't get to them, I'll try to get to them at the end. But so here are the 4 fundamentals that are unique to cloud security. Oh, see, I got a question already. What do I mean by lowering the reporting threshold? What that means is if you notice an anomaly in your network, if you notice something that's off, be a little bit more sensitive to that, right? There's lots of weird things going on, but if you notice something that's weird, try to take it seriously and potentially report that to CISA, right? They've got some reporting guidelines on their website. Because if they get a similar report from 5 different places, then maybe it's not such an anomaly anymore, right? But they can only know that if you report it. So I hope that answers your question. Just be a little bit more sensitive in this time. Okay, so fundamentals of cloud security. The first one is to understand the shared responsibility model. And each cloud provider has their own specifics on this, but the broad concept applies across all cloud providers. They will take some responsibility of cloud security, right? They're going to secure the data centers. They're making sure that bad guys aren't walking in the front door. And they're taking care of the power and redundancy of their power providers, things like that. But you are still ultimately responsible for how secure your workload is. And in particular, all the configurations that you apply are your responsibility, right? If you set a resource to be publicly available, you can't blame your cloud provider for that. They will do their best to make things secure by default or give you the tools, but you're responsible for understanding the impact of those. Okay. The other thing to know there is that there's kind of a continuum in the cloud of how much they manage, right? So on one end, it's like I'm spinning up a virtual machine and I'm in control of pretty much everything from the operating system to the application and the networking. They're of course taking care of some of the physical things, but you've still got a lot. On the other end of that spectrum, it's more like function as a service or platform as a service models where you're just providing some function code and they're executing it, right? You don't have any control over the operating system. In general, you want to leverage that, right? Let them secure those things. It's one less thing for you to think about. And so that's how you can use the shared responsibility model to your advantage. Okay. The second fundamental here is that you should refactor your security architecture during cloud migrations, right? So if you are moving things to the cloud, it's really not recommended that you just lift and shift whatever you've got in an on-prem data center into the cloud because they just aren't the same, right? So the assumptions that were built into your security architecture just might not be the same anymore. In particular, there's less of a need to worry about like firewall configurations and extra packet inspection, particularly because you can use firewalls that are kind of cloud native firewalls that limit network traffic, and you just need to worry less about like centralizing network routing and inspection, unless you have a real need for that. What else? So there's also some considerations. For example, cloud networks don't allow passive sniffing of network traffic, right? Like if you're in an on-prem data center, you've got a switch and traffic's moving across that switch. You have to worry about like ARP poisoning, or you have to worry about things where somebody might be able to get your traffic. That's just not happening by the cloud design, and so you just don't need to worry about that as much. Ultimately, just refactor your security architecture with some new cloud assumptions. Okay. The third one is consider threat detection and response. Now, we should be doing this anywhere, right? We should be doing this in on-prem, but really in the cloud, you have more automation and detection ability than we've ever had before. So you should be considering that ahead of time. enabling threat detection services, many of which are not enabled by default for you, and thinking about your responses and not waiting until you have an incident and then going, oh, okay, how do I respond to this, right? How do I do forensics in a cloud environment, right? Well, on-prem, I'm going to go pull that hardware out, and then I can put it into an isolated cage and do forensics on it. Well, you can't do that in the cloud, right? So if that's a need for you, think about how you would respond to that. And there's ways to do all that, right? You can stop a virtual machine, disconnect its storage volume, put it into a private subnet, right? So you can still do the same things, but it's going to look a little bit different, and you want to have a bit of a plan for that. Okay. Then the fourth fundamental I've got here is that we want to build security into every layer. And again, you've always been able to do this, but cloud makes it even easier than ever. It's just not out of the box, right? So we're building defense in depth. We're thinking about the security of our cloud configuration through the network, through the application and the operating system. We're thinking about all those layers and trying to build security into it across the board. And we're going to talk about some ways to do that here as we go forward. And let's see, I'm seeing a couple questions come in. So one is, what is the most secure cloud today? You know, that's an interesting question. It's hard to say exactly, but I think my safe answer here is that any of the major cloud providers are sufficiently secure for you to trust them with your workloads. Now, there have been some recent incidents that may undermine your confidence. Azure, for example, has had a couple recent things that allowed, access to customer data and workloads that I would say undermine people's confidence in Azure. But the truth is, they are so much more likely to do a better job of this than you are on-prem. For no other reason than they are hiring the best people at this, paying them more than most companies can pay them, and focusing them on, really high-tech, really modern data centers and architectures. So I wouldn't worry about security of the cloud. I would worry about security in the cloud, which is ultimately your responsibility. And then I also see a question here, what is the biggest threat today? And I think that's a good question. It's going to vary depending on who you are, what workloads you have, and generally what your threat model looks like. But some of the most common things that we're seeing are things like phishing, right? Especially spear phishing. If someone could detect who is going to have privileged access into your cloud, and they can gain access to those credentials, that can be pretty significant, because now they've got access to all of your cloud resources, right? In particular, your Office 365 admins are particular high value targets, right? And if they can be phished and get their credentials compromised, then that's a big deal. And the solutions to that are the kind of straightforward solutions that we always think about: multi-factor authentication, conditional access to make sure that those credentials aren't being used somewhere else. So they're kind of the common controls that we'll think about, but the biggest threats really are phishing and you making mistakes in the cloud that open yourself up. So we're going to talk about a few ways to prevent that from happening. The the National Institute for Standards and Technology, NIST, has a cybersecurity framework where they have 5 categories for cybersecurity. So identify, protect, detect, respond, and recover. And the truth is that in the cloud, many of these are deeply linked, right? So detection and response, for example, well, everything I detect, I need to be prepared to respond to, right? And I can't protect something if I don't know about it. So identify and protect are deeply linked. I've taken these categories and laid them out into 9 different functions here nine different categories here that we're going to go through each one and think about how do we do this for each of those categories. So the first one is account management, and this is one of the things that you need to do upfront in order to identify what your cloud resources are and where they reside. So regardless of your cloud provider, you should maintain some inventory of your accounts. That may include root email addresses, which primarily applies to AWS accounts, but also account or subscription IDs, points of contact. Who runs this account, right? Who knows what's in here? If I got an incident that said, "Hey, there's something in this account," who would I go to, right? And then a significant part of this is that you should identify shadow accounts, accounts that you don't know about as much as possible. So this is really common. Somebody sets up an AWS account, either they're tinkering and then that tinkering becomes significant and now it's a production deployment, or maybe not, right? Maybe they still have sensitive data, proprietary data in there. You should identify those and try to bring them under control. One of my favorite ways to do this is by asking, right? You can go to your AWS account rep, for example, and say, "Hey, can you tell me about any accounts that are registered under my email domain?" Now, it might be under a personal domain, but they could still try to help you with that. Or reviewing expense reports. Going to finance and say, is anybody expensing an Azure subscription, right, or an AWS account? Because that happens, right? They need to set something up and they don't want to go through your processes. So find out about those, bring them under control, especially before they get compromised. And then once you know about them, set them up in some sort of tiered account structure that you can manage, right, and apply restrictions on them. So AWS has service control policies, Azure has Azure policies, but put these together and figure out if this is the right structure for you. Accounts should be separated between different workloads and environments, access and management patterns. But ultimately, you want to think about, do I have them all, and am I applying some restrictions on them? And in almost all cases, there are policies that make sense. So I want to prevent you from disabling logging and alerting. I want to prevent you from using non-approved regions, right? If we are U.S.-based and we've got a policy that says you can't put anything in outside the United States, then deny access to that as a policy. You probably have your own things in mind there. Okay, so the next category here is human access. All right, so I've got control of my accounts. I know what accounts we have. Who can use them, right? The most significant thing to do upfront is restrict usage of that, that global admin or that root level access, and say this can only be used to create less privileged users, or primarily to configure my single sign-on. And then after that, we're not going to use it except for a break glass scenario. So in AWS, there's a email address that ties to that root account, and you really need to take steps to protect that. And in Azure, you really shouldn't have a big long list of global admins, and they also have ways of restricting that usage on a day-to-day basis. And the best way to set up your human access is, of course, with single sign-on. Single sign-on really should be a fundamental aspect of every cloud environment. Unfortunately, it's still very common that people use usernames and passwords, even without multi-factor authentication. So it can be hard to determine who is this user, and and if that is a privileged user, that is a significant vulnerability right there, right? If someone gets that username and password and now they've got admin, that's all they need. That's not good. So you should use single sign-on, require multi-factor authentication, really across the board, but at minimum for all privileged access, any access to sensitive, confidential, proprietary data, and any accounts that represent official communications, right? If you've got something that's publishing your website on a cloud service, protect that. You don't want somebody taking that over. And then after that, really start thinking about fine-grained user permissions, right? So not everybody needs admin, right? In Azure, owner privileges over every resource group. Think about what they need, try to scope that down. That will take a little bit more work, but each cloud provider has some tools for helping you do that. And then lastly is, this is not really set it and forget it, right? Once you set up that access, you need to periodically audit it and remove unused credentials. You will have people who will leave, and you'll find, old accounts. They created a user account for some service that they were doing, and now it's no longer there, but it's got, admin access still, and it hasn't been used in 180 days. Get rid of that, right? You don't need that sitting around to be found later. And so get rid of that. Let's see. I see a question here about any cloud services we should stay away from. What about open source clouds? Nothing comes to mind on cloud services you should stay away from. You might evaluate their origin, what country they're hosted in, and see if that applies to you. But it's difficult for me I'm not going to put any cloud provider under the bus today. But yeah, I do recommend sticking to one of the major clouds, and that might include, Hertzner or DigitalOcean, if those apply to you. It doesn't have to just be AWS, Azure, or Google. You can use some of the other smaller cloud providers, and that might fit for your needs. Okay, so we've got we talked about account management. We know what our cloud accounts are. We've set up human access, so we're using single sign-on to get into our accounts with least privilege role-based access. All right, that's a really good fundamental start right there. The next category is machine access, or really kind of like service accounts, things where some machine is calling my services. The most important thing, and this is one of the common misconfigurations or common errors, is you should really never embed credentials directly into code, right? So if you've got a database that uses a password and your application needs to talk to that database, that should never be embedded into code. That should never be committed into Git. And you really need to be careful about where you put those credentials. all of that access should be retrieved programmatically, right? So each cloud provider has some sort of secrets manager where your application can go get the password as needed or go get that database connection string and connect securely, and it doesn't remember what that password is, and hopefully won't ever put that into logs or someplace where it's going to be revealed. Unfortunately, all the time, people's credentials get committed into Git, and then they have to scramble for how do I revoke that access, and was it inappropriately used? You can prevent that by just not embedding them in the first place. And then, especially when it comes to machine access, you have the ability to scope down those permissions to least privilege. A lot of people say, well, this is just going to be called by some machine. It's not going to do anything. It's not going to do anything malicious, right? This is not a malicious actor, but you never really know where those permissions might end up. So they might be compromised, and this is one of the ways of reducing the blast radius, if you will, of a compromise of those permissions. And ideally, those should be programmatically retrieved and temporary. So in almost all cases now, you can use temporary credentials instead of long-term credentials like passwords or access keys. So for example, if you're using GitHub Actions to deploy into your cloud account, you can use OIDC, which will generate temporary credentials, and you don't need to give GitHub Actions a password or an access key into your cloud. Now, it is technically secure to give GitHub Actions a secret where they technically will store it as a secret and it can't be retrieved, but why would I if I don't have to, right? So watch for machine access. Okay, so we've got accounts managed, human access, and machine access. Now we're going to look at the infrastructure that we're actually running in our cloud and thinking about how do I protect that. The first thing up front is just limit your exposure to the public, right? If they can't see it, then it's going to be a lot harder for them to probe it and find vulnerabilities if there are some. So really limit those. Now, some will be intended to be publicly accessible, but not everything. So limit that. And then even beyond that, try to establish network topologies that limit routing between those resources. If the only thing that ever contacts that database is this specific application, then limit that database's access to that application. Don't allow it from anything else, even within your cloud, to prevent lateral movement. So this is not unique to cloud, but this is something that's a lot easier in cloud because I don't have to just specify IP addresses, but I can also specify a resource by its name, right? Or a security group of other resources, and that will be a lot more secure. Okay, so the other way to protect infrastructure, especially public-facing applications, is using web application firewalls and distributed denial of service protection. Because anything you have that's public can be hit, right? There's no telling whether or not you'll be the target of an attack, of a denial of service attack, but you want to be prepared to have that. And each cloud provider has some protection for this, and you'll need to set that up depending on your needs. Particularly, web application firewalls are helpful because they can reduce the noise on your application. They can reduce your costs, actually, right? So if you're getting hit with a bunch of requests from bots, for example, the AWS web application firewall can filter out those bots so your application isn't getting run down by a bunch of bots that are not your customers, right? So use web application firewalls there. The other thing is web application firewalls can help prevent against like SQL injection attacks. So if you're running an application that you're not necessarily sure whether or not you've sanitized SQL input, a web application firewall can try to prevent those malformed requests from reaching your application. Now, that's not a complete solution, but will certainly help. And so we're talking about defense in depth here. The other thing to do to protect your infrastructure is to just limit your exposure of any services for manual administration, right? So remote desktop and like SSH access, which many of us have used for a long time to get into our virtual machines and perform a patch or an upgrade or look at the logs. The cloud provides us much better ways to do that, and as much as possible, let's disable those services, right? Then nobody can get into my SSH because I don't even have SSH enabled. So there's many different approaches to doing that, but use automation for your deployments and maintenance, and don't have those manual administration tasks on. Some of the most common ways that we see for this are, creating a machine image that gets deployed to a new virtual machine. So that new image has all the new updates and all the changes, and it replaces the old one. So that's a technique called immutable infrastructure. I never changed that machine. I just made a new one and replaced it. There's other techniques. For example, AWS has Systems Manager, which can use an agent to deploy changes or retrieve resource inventory, things like that. And so you don't need manual administration, and that's just automated. So those are some pretty strong ways to protect your infrastructure. Okay, how do I protect the data that is also in my cloud? Well, the first one I would say is to really consider what data services you're using in the cloud and how you've set them up. A lot of times when we create data in the cloud or we migrate it there, we're maybe not very deliberate about where we set that up because we just needed to get it there. But that configuration is really important to get right. Am I using the right tier of storage, for example? These can actually be pretty confusing in cloud providers, even AWS and Azure, and they change them. They've got cold tiers, hot tiers, globally redundant storage. I've seen cases where people thought their backups were going into cold storage, but it was actually going into hot, globally redundant, replicated across multiple regions because they just didn't realize what boxes they were checking. So be very careful about that. But in some cases, if you want to protect your data, then you should be thinking about replication and your resilience requirements. So that varies, and the important thing here is that you don't want to configure a bunch of replication and resilience that you don't need, because then you're going to pay a lot of money for that. But it does need to be at the level that you require. So think about that pretty carefully before you set everything up. And then data encryption in the cloud is, it's an important thing to make sure that you're checking the boxes, right, for encrypting the data at rest and in transit as required. Now, it's unlikely that your data is going to be compromised in the cloud, and encryption will be the major difference. But it's still it's easy enough to do in the cloud. It should be your policy, so make sure that you're applying that. And then I think an important tenet of data protection here is to get rid of data that you don't need, because if it's not there, it can't be compromised. And if it's not there, you're not paying for it. And if it's not there, then someone doesn't have to come along and worry about it later and say, who created this data and do we still need this? I see that all the time. People don't want to get rid of data that's 4 years old. No one's ever touched it. No one knows what it is, but maybe they might. So when you create that data, set a data retention policy, right? Set a tag or some sort of description that says what this is and why you set that data retention policy. And hopefully it will just delete itself when you don't need it anymore. That will help a lot with GDPR compliance, where you can't be storing people's data that they don't need. So, so just automatically destroy it. That's one of the great things about the cloud. And then consider your data access, right? Just because someone's an administrator of an account, because they're setting up the infrastructure, that doesn't mean that they actually need access to the data that's within that. You can use your cloud permissions to let them manage the data, but not access it. So if that's PII or some sort of confidential data, think about those fine-grained policies. And also look to your cloud provider for automated discovery and classification of sensitive data, right? So you put it into the cloud, you're like, I don't know if this has sensitive data or not. Well, there's services for that. AWS has the Macy service that will scan it and can use their machine learning techniques to determine if there's sensitive data in there. I see a question in here. What is a good level of encryption? The most important thing here is to not just look at, is this 256-bit encryption? That really doesn't mean too much. All cloud providers will offer a variety of encryption like schemes, but as long as you stick to their recommended schemes, it is definitely going to be good enough. But you can, of course, bring your own encryption keys and techniques if you want. And you can, of course, encrypt it before you put it in the cloud as well. I think that's an unnecessary level in most cases. But yeah. So let's see. Yeah, I'm not going to get into specific encryption schemes, but the standard ones that come with your cloud provider are definitely good enough. Shouldn't you work with business users to determine what data is needed and for how long? Definitely, right? So when that data is created as part of an application, and you should definitely be looking, working with your business users to determine that. Absolutely. And that's what I mean is a lot of times we don't have that coordination up front, so we decide to just keep it forever. And that's not a great option either. And I know that business users will often say, well, I don't know, can we keep it just in case we need it? And my honest answer to that is no, right? Like if you can't give me a reason to keep this, then I'm not going to pay for it. I'm not going to manage it. I'm not going to take on that burden. But that is definitely a decision that needs to be made collaboratively. Will the cloud providers provide details like what encryption they're using? Absolutely. Every single cloud provider will tell you that, not only in their service description, but also right as you're selecting it, right? So AWS Key Management Service, for example, their frequently asked questions page will tell you all the details that you need about their encryption. And if you need even more specific details, then your cloud provider can, under a non-disclosure agreement, give you even more detail about what they're doing on their side. AWS will give that to you through the AWS Artifact service. It'll give you non-disclosure agreement protected details about it. And yeah, you'll definitely know. Okay, so we've got our infrastructure and our data protected. We're going to start thinking about logging and visibility of our cloud environment. So all cloud providers are going to have some log system, right? So AWS has CloudTrail, but everything's going to have a cloud, have logs of who's doing what in your cloud, who's calling APIs, and you should be sending that to some centralized log storage. I do recommend across all of your accounts trying to put those into one place so that you can query and protect those logs all in one place. The hard part is querying those logs when you need to, right? So AWS provides 90 days of logs that are available just to query right there in the AWS console, but its query capabilities are limited, right? It really can only look at one dimension. So you can say like, give me all the logs for this user, or all the logs from this service or this specific event. But if I want to say, tell me all the times that David made an action in S3, I can't do that right there. So this is where you're going to look to some log management capability, either third party or within your cloud that will allow you to do those query capabilities. Now, in enterprise environments, you likely want to have some sort of SIEM, some security incident and event management system, where you can do that all together. And it's not just your cloud logs, right? But it's also application level logs, network logs, and anything else you think is of value. So just think about, how am I going to investigate when something happens? And, track inventory and configuration history. AWS has a config service, but every cloud provider has some service for this, where you're thinking about what was the history. You want to know who made changes and when, and you should be thinking about how will you track that. And resource tags, right? So you can apply tags to data or other resources, and you should be thinking about how critical are these? Is this just a dev environment and this data is not important? Let's call that out so that if somebody finds it later, it's not a big deal. But on the other hand, if this data is really important, it's sensitive, and it needs to be retained, or whatever it contains, you should have some tagging strategy for your enterprise environment that says, this is how we're going to designate categorization and criticality. And then my other tip here is that service-specific logging is available, but I don't think that you need to make it a priority to enable that on everything. So network flow logs, for example, or data access, these can be very noisy, right? There's lots of network flow and data being accessed in the cloud. If you don't have a way of consuming that, querying it, making sense of it, I don't see why you would pay to store all those logs unless you have a specific requirement to. So I don't recommend making it a priority to go and turn that on everything unless it's part of a bigger plan for what am I going to do with it. Okay, so now we've covered most of the protection of our cloud, right? We've identified things. We've talked about how to protect lots of different categories of resources. I want to start thinking about, how am I going to detect what threats I see and how I'm going to respond. But ultimately, each cloud provider has some capabilities here. You want to think about turning on threat detection capabilities, where it's either preventing threats through identifying weak configurations, like, hey, you've got this publicly available. Do you really need that? But also detecting, hey, this behavior looks suspicious, and that is informed by their kind of threat intelligence and the patterns that they've observed. So use your cloud provider to enable those threat detection capabilities and start thinking about incident response. So you should have incident response plans that include some procedure for notifying your cloud provider, hey, I'm being hacked. Like, can you assist me? And how am I going to coordinate with them? Who do I contact? And then also, how am I going to let people in, incident responders? How am I going to get my security team access to this environment in that scenario? And wherever possible, use the cloud to automate remediation of weak configurations, right? So you might have a rule that says, if I detect a public storage resource, turn it to private unless some condition, right? So that no one can accidentally make data public, and it'll just automatically flip that over. And then recovery. So the difference between response and recovery is that recovery is to think that you have actually been compromised to some degree. What do I do now, right? And this should be a discussion between your business and your technical people, but what are the disruption scenarios that you might encounter? What would happen? What would be the failure modes? Like, okay, so someone has compromised this. Now this service is no longer available. How do I respond? And I like to clarify the difference between high availability and fault tolerance versus disaster recovery here. In particular, high availability is saying that you will agree to a level of performance that's higher than normal, but you will accept some amount of downtime. Fault tolerance really is that I don't want to accept any downtime, right? Failure is unacceptable. Fault tolerance is definitely more expensive and difficult compared to high availability. And then disaster recovery is all the policies and tools and procedures that will help you stay alive when your fault tolerant or high availability systems didn't work. So my comparison to this is that your spare tire on the car is high availability, right? You're going to break down so you can get back up on the road. Fault tolerance is redundant components, right? I'm flying a plane and I've got 2 engines or maybe 4 engines because if one goes down, I need to be able to keep flying. And disaster recovery is your ejection seat, your offsite backups, and what am I going to do when everything else failed? So plan that in advance. And one of the best ways to prepare for recovery of your cloud infrastructure is to define all your cloud infrastructure using code, right? Backing up all those configurations and scripts and protecting them. If someone compromised your source repository, and deleted all your code, you would lose everything. So definitely protect that. But if someone got into your cloud account and deleted everything that you built, but you didn't have any scripts to put that back up, you would be starting from square one. So write everything as code, back it up, and really protect that from deletion. Okay, so I've covered a lot of topics here. I want to end just with these 4 guiding principles that are not just cloud specific, but this comes from CISA's guidance. Reduce the likelihood of a damaging cyber intrusion, right? So do everything you can to reduce that likelihood. Take steps to quickly detect it if it happens. Ensure that you're prepared to respond if something does happen, and maximize your resilience to an incident. Those really are your guiding principles And I encourage you to not overemphasize one over the other, right? Don't say, I'm going to get attacked. I don't need to bother with prevention, right? That would be crazy. But also saying, well, I'm just going to spend all my effort on prevention, and then I never have to worry about responding. That's just naive, right? So you need to think about it across the entire life cycle of a potential intrusion. And that's it. I mean, that is Cloud Security 101. Okay, so I've covered a lot of information here. I'm open to any additional questions. What else is on your mind?
Thanks, Stephen. I wanted to just remind everybody, pardon me, we still have a few minutes left. So be sure to type any questions you might have even now, and we'll do our best to get to all of them. Stephen was really good about getting to your questions throughout the presentation, but there are just a couple here maybe. So this one is, the question is the cloud really secure? I guess I would modify that a little bit and say, is the cloud ever really secure because it's just someone else's data center?
This is definitely one of the common things that people worry about. And my answer is, it comes back to that shared responsibility model. I think that the top cloud providers are doing a great job of protecting their clouds and giving you options, but you really do need to kind of finish the job, right? You need to ensure your configurations are appropriate to your requirements. And I know that personally, I would not bet that I could do a better job of securing a cloud than Amazon, right, or Microsoft. Even if they do occasionally have shortcomings, I don't think I'm going to be able to do better than them, especially at my budget, right? So, my answer is yes, the cloud is secure, with your help.
Okay, here's another one just came in. It's Roland, and he's wondering if I had to sort of establish my priorities, what would be the highest risk of using the cloud for my business application?
The highest risk from my perspective is that you may inadvertently expose credentials or data or some aspects of your cloud application, and that's putting you at risk, right? So if you are logging into your cloud account using the root user every time you're making a change, and you're using the access keys for that root user on your command line, right? And you're pushing to push changes, then what that means is that the weakest link to your account is your laptop, and someone getting control of your laptop and scraping those credentials now owns your entire business application. So that would be one. And then the other one is just like, if you're using, the most common answer is like Amazon's like S3, like you create a public bucket to host your website, but you also have a bunch of data in there, and it's like sensitive data or whatever. Well, you just exposed it, right? So those are the highest risks, I would say. And if you get some of those basics right, then you're going to be ahead of at least half the people out there.
So we've got maybe time for one more. This attendee is wondering how you approach building a hybrid cloud environment, and I'm guessing what they mean is from a security angle.
Sure. So let's see. So hybrid cloud, in this context, we're thinking we've got, cloud networks and on-prem networks and some amount of communication going across them. Now, one of the most common architectures we see is my cloud environment has a VPN, right? So some sort of secure tunnel back to on-prem. And for resilience, we create 2 of those tunnels, and they connect to different routers that are, we've got really good redundancy there. I think that's fine, but one of my common questions with hybrid cloud is like, but what's going across that link? And why can't that just go over the internet, which actually is much more resilient than even those 2 redundant links, right? And I know in some cases people do want them to go directly, but most of the time, if you have that properly secured and encrypted, that communication you should not worry about that going over the public internet. So that I just want you to, as you build a hybrid cloud, I want you to challenge what is actually hybrid about it. And I would say that in almost all cases, you're not going to have applications that are half on-prem and half in the cloud. And if you do, then I would challenge, like, why, right? Like, why would you have 1 foot out the door and 1 foot in? Shouldn't you just move it all to the cloud? So that's my general approach. Now, I understand that people are going to often do that in phases, and I think that's okay. But my aim would be to not get stuck between those 2 worlds, right? Like, definitely commit to going to one or the other, or at least, operating in parallel and saying, like, I'm going to put this application in the cloud because this benefits from the scalability and elasticity of the cloud. Meanwhile, these things I don't want to, and those are going to be run by distinct teams that can focus on what they do best. So, hopefully that answers your question there.
Well, thank you, Stephen. It looks like that's all the questions we have time for. Many thanks to Stephen Smiley for a great session, and to our sponsor, Rubrik, the Zero Trust Data Management Company, for making it possible. We're going to take a short break now, and we'll be back at the top of the hour for our second session, Cloud Security 102, Expert Cloud Data Security Best Practices, which will be presented by Joey D'Antoni, Principal Consultant at Denny Cherry and Associates Consulting, and moderated by my colleague, Editor Extraordinaire of Virtualization and Cloud Review, David Rammel. Now would be a great time to check out those extra resources on your console provided by our sponsor. And remember, during today's second session, we will be giving away a brand new HP 15.6-inch touchscreen laptop. You must be present to win, so stay tuned. Back in a few.
Okay, welcome back, everyone. Thank you for being here. And thanks to our sponsor, Rubrik, for underwriting this summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, here to moderate the second session of our summit called Cloud Security 102, Expert Cloud Data Security Best Practices. Our speaker for this session is Joey D'Antoni, Principal Consultant at Denny Cherry and Associates Consulting. Joey is a VMware vExpert and a Microsoft Data Platform MVP, and has over 20 years of experience working with both Fortune 500 and smaller firms. He has worked extensively on database platforms and cloud technologies, and has specific expertise in performance tuning, infrastructure, and disaster recovery. Joey, it's great to have you here. Please take it away.
Thanks, David, and welcome, everybody. This is a cool talk I put together yesterday, just a bunch of really interesting topics. Steve, for those of you who were on earlier, Stephen's session was really interesting, and he talked about a lot of things I'm going to touch on, but we're going to go into kind of deeper detail. But I just wanted to start out with a story from my morning, because it was kind of interesting. So this morning, I live in Philadelphia, and last night I had a dinner with a client in New York. So I spent the night there. I took an early train back so my wife could get to work on time. And as soon as I got home, one of our clients had an AWS VM where someone had accidentally deleted a database VM. And so the first thing I jumped into after I got home with a couple of my colleagues was working on how to get their databases restored. And fortunately for them, no one had deleted the data drives. It was simply the VM and the OS operating system drive. So we had to restore a new image. It was a SQL server, so we had to restore the master database from a backup. And then the database is able to see all the other databases on the server. But just goes to show you, it can be pretty easy if you don't take the right precautions in place to have resources go away in the cloud. And we're pretty confident this wasn't anything malicious. It was, somebody just made a mistake. But if you're not careful, bad things can happen. And ultimately, we had a few hours of downtime. Probably should have been a lot less than that, but be careful. So the correct solution, what they should have done, if they had been in Azure, there's a resource type called a lock that will prevent a VM from getting a resource, any resource actually, from getting deleted. And AWS has something similar as part of the resource definition where you can prevent it from being deleted. And I also think there's a soft delete option. This was not soft deleted. And what soft delete means is the resource isn't physically deleted from disk, so you can still recover it. But that was my morning, and that's about the worst kind of cloud data security you can have is to delete something that is of critical importance. So cloud services, when it comes to security, we have shared responsibility. And I always like to talk about this in terms of patching, right? The bug I always go back to is the Intel bug that happened in 2018 because it touches all of computing for the most part, unless you're running on AMD. But if you're on premises and you manage your own hardware and infrastructure, when that Intel bug hit, you had to patch the BIOS on all of your servers. You had to patch the hypervisor, so the virtualization platform you were using, whether that be VMware, Red Hat, or Hyper-V. You then had to patch the operating system on all of your servers. And potentially you had to patch even more than that. Like if you had Oracle and SQL Server, for example, both required patches after that to address security risk within the database engines themselves. So you had to patch all those things, and you probably still had to patch your mouse. If you're running infrastructure as a service, your cloud provider did all that stuff in green. So what that means is the BIOS of the servers, they were patched by the cloud vendor. The cloud vendor patched the virtualization software, so you didn't have to worry about that. In fact, I know at least at Microsoft, there was downtime. They sent out an email and said, hey, we patched your servers. Sorry, we bounced your servers. Hope you're ready for that. But you were still responsible for patching your operating system and any middleware or runtime software that needed to be patched. However, if you're running on a managed, let's say, database platform, like RDS or Azure SQL Database, you didn't have to patch anything. Your service was just patched for you. What you do still kind of manage, and this isn't totally clear in the slide, is even if you're using platform as a service offerings, you still do need to use, you still need to manage security. So you control who has access to your applications and data. And that's really a key part of this when we talk about data security. We're going to talk about encryption a little bit later in greater detail. But encryption and who has access to your data and what services have access to your data. And as you start to share data across organizations, that becomes more of an issue. And then finally, software as a service, the vendor manages everything. But the one key point I want to make about software as a service, and when we talk about Salesforce, when we talk about software as a service, I got ahead of myself there. We talk about things like Salesforce or Office 365 or anything where you pretty much can just consume and you don't do too much configuration. You still manage user access and control to that. The vendor does not do that for you. So taking care of who has access to what and that access control is still kind of a key importance when you're managing software as a service system. So remember, your user security is always your responsibility. And it really helps when we take a defense in-depth model. And some of this we don't have to worry about in the cloud, and it's mainly this factor. To an extent, the physical security. So if you've ever been to a tier 1 data center, I had the good fortune to get to go to a data center for a stock exchange one time for a project. It's absolutely serious in terms of the security that's in place. There's 24/7 security. The buildings are typically unmarked. You get inspected more heavily than if you were going through an airport. There's barriers and fencing to prevent cars from taking out power. Two-factor access control, typically days of backup power. You don't have to worry about this. Amazon, Azure, and Google, they do that for you in the cloud. What we do have to start to worry about, though, is everything else. The other layers are all on us. Networking, so making sure we have secured and isolated virtual networks. We have valid access control list on our network, so we're only allowing the traffic we want. Forced tunneling, so maybe we're routing traffic through a firewall, through a user-defined route. In some cases, you may want to use security appliances to add additional security measures beyond what your cloud provider is using. For example, third-party firewall solutions from various security vendors. And you can also have multiple NICs to segregate your traffic. I know this is really about cloud data security, but one of the things I find is data engineers and database administrators really have to learn about network architecture in the cloud. And I don't think it's because we don't have enough network architects, but I think we don't have enough cloud network architects. So people who built networks on-prem haven't fully transitioned to the cloud. So a lot of times the people who are working on the systems themselves have to kind of become more expert in in networking technology than they otherwise would. I know for a fact I have. It's something I've seen in my own career. And networks, one thing about networking in the cloud is because it is all virtual and it's all software defined, it's easier to build more secure constructs. So like doing things like isolating virtual networks is a lot easier than it would be in an on-prem world. In terms of infrastructure, we want to think about doing things like operational security controls, compliance certification, making sure our infrastructure is secure by design. You want to think about things like not reusing credentials, so maybe having two sets of credentials for your admin users, or even having just-in-time access to the infrastructure. Like Stephen mentioned, you want to make sure you have forensics. So you want to have logs on everything. You want to aggregate your logs to a central location so that you can query all events. That's kind of a key part of security. In terms of VM, you want to have anti-malware in place, obviously. You want to have any security extensions from your cloud vendor. It's important to understand that you have role-based access control and logging and auditing, like we mentioned. We're going to talk a lot about encryption. I feel like a lot of the encryption at rest stuff we're going to talk about in a cloud world isn't that important, but it is important to meet your audit standards. So you do want to use that. I know Stephen talked a little bit about that. Encryption at rest simply means the files as they're stored on disk are encrypted, but anybody who has access to those files can open them. So having this kind of multi-layered security model is really considered a best practice. I was reading Twitter, and I follow a bunch of security experts, and there's a gentleman who used to work at Microsoft who's now working for a company in the UK who was talking about this yesterday. A lot of times, security vendors will kind of try to come in and sell, do your own zero trust architecture security, and they're trying to sell them to organizations that run a lot of legacy hardware and software. It's not, and the comparison that the guy who was tweeting this made was, you're not born ready to run a marathon. You have to train for it. And security kind of works the same way. You're not going to implement a super secure environment right off the bat. You have to start with baby steps, maybe making sure you have MFA enabled for all the user logins you can, separating out admin accounts. That's something else that's easy. Network segregation is the next step. So there's a lot of planning, and sometimes it'll be re-engineering. Sometimes you'll have to rebuild some stuff because you're going to break stuff when you do this. And it's important to really understand that. And this all ties into data protection because we don't want our data to be breached. But we can't just protect at the data layer. We have to think about all the other layers where we have to protect things. One of the great examples of this is user credentials. Identity management was something I never really thought I was going to have to worry about in terms of as my career as a data professional. When I started, I wasn't that interested in things like Active Directory or LDAP or anything, but credentials are constantly at a risk of breach. And this is especially true for those of you who are administrators. And that's one of the reasons why I mentioned, and I'll keep mentioning, separating out your admin accounts. One of the ways a lot of malware and encryption software works, or ransomware, sorry, I can think of the word for a second, is the ransomware will install itself onto your network quietly, and it won't do anything for a while. And what it's trying to do is look at memory as it moves laterally across your network. And if it can find cached, for example, Kerberos tickets of an administrator, it can use that ticket and use those credentials to move all across your network and then start doing bad things. So that's why credentials, and that's why multi-factor authentication are so important. So credentials theft is a big thing. Use secure passwords. 73% of passwords are duplicates. So the one thing I want to tell you that you should do in both your personal and professional lives is use a password manager. Using a password manager has really completely changed my life and how I interact with the world, because I don't really even know I couldn't tell you what my bank password was if you held a knife to my throat. It's some really long encrypted string that makes no sense. It's stored in my password manager, and that's how I get to it. The other thing I'll tell you is enable multi-factor authentication everywhere you can. If you get a multi-factor authentication notice for, say, your bank account and you didn't log in, you should probably be concerned and call your bank, and they typically have a mechanism for that. But the same thing applies for corporate systems. The other thing that's important, and this is tricky to manage in terms of data breach, right? 80% of employees use non-approved apps for work, and as more and more people are working from home post-pandemic, this is something that's also a concern, because it's easier to have data exfiltration, and the controls you can have in place are harder. It's a lot easier to maintain network security within the four walls of your building. But if, for example, you have a user who jumps off VPN and where you're not managing the network connection, and then goes to a website like Dropbox and pushes data offline, that can be a lot trickier to manage. So we have to look at more advanced solutions to reduce the risk of data exfiltration. And if you're not familiar with data exfiltration, it's just as data moves off of your environment, and that's a big risk, especially in a distributed world. By the way, feel free to type in questions at any time. I'll keep my eye out, or we'll answer them at the end. But when we talk about security and our best practices, it's important to think about a few things. Cloud security is multifaceted and complex. There's a lot of layers here. And when we talk about data systems, there's even more layers. And I think when we talk about cloud data, we really talk about two things. And so I'm going to work back from the data layer. So we have storage accounts that store files and objects, and those are S3 and Amazon and Azure Blob Storage, and I think Google's is just called Google Object Store. Those services store data. That data can potentially be exposed to the public. You want to be exceptionally careful whenever you have a storage account or a storage bucket that is sharing data publicly. Those things work great at what they do. So one of the things they're designed to do is just like host a static website. So if you wanted to drop an HTML page in a S3 storage bucket, that's a very easy way to get a website up and running. However, I always wondered, and I have a slide talking about data breaches, and might be a slide or two away from here. One of the most common attack vectors for data breaches is open S3 buckets that are open to the internet. And I do more work in Azure than I do Amazon, and I didn't understand why that was the case, but I was building a proof of concept for something in Amazon that had to work with S3. And it wasn't a scenario where you could accidentally leave it open. Amazon did a good job of doing that. It was pretty explicit when you opened it up to the public. But on the other hand, in order to allow private network access to my S3 bucket, I had to go to a whole different screen and execute a different set of JSON to define the rules. It wasn't super, super obvious to me. And when it didn't work, the troubleshooting path was kind of challenging. So a place I feel like Azure is a little bit easier to work with there, but it helped me understand. So locking down those resources, things, and Stephen mentioned this earlier, one of the bigger risks you have in cloud is that you can make things public. And you make things public and they shouldn't be public, then people can potentially access them. With storage accounts, those are all just HTTP files. So if that storage account's public, anybody who can see it can download it. Databases are a little bit different. Like some of the cloud databases allow for a public endpoint, but you'd still need to authenticate into the database. So the first thing you want to make sure is you want to lock down those things. Don't leave public things where you don't need them. Then the other thing that's kind of key to that is access control within the cloud. And we use something called role-based access control, and it's kind of a common term. I think we're all familiar with roles. But role-based access control is the way we define cloud security. So that's who has access to the control plane. Let's talk about that on the next slide. So the key things with role-based access control, and this is pretty universal across Azure and Amazon and GCP. There are some nuances to how they're implemented differently. Is three main roles: reader, and reader does exactly what it sounds like it can do. Reader can make no changes. Contributor can make all the changes, but it can't grant access. And then owner can make changes and grant access. There are different roles, so there are more nuanced roles for specific services, but those are the general roles that apply. The other thing beyond those roles that you want to understand is the scope of the roles. So I'm going to use Azure because I know it a little bit better than Amazon. In Azure, we can scope things at 4 different levels. So we can scope security at 4 different levels. So we can scope at the lowest level is the resource. So if I give you owner of an individual VM, you can do anything you want to that VM, and you can change. You can make changes to it. I can then scope at a resource group, which is all resources belong to a single group. So I can group multiple resources, and that's in Azure. That's the most common scope for resource assignment. I can then assign things at a subscription level, and that might be where I define my who's running the subscription. And these roles will all cascade down. That's the important thing to understand. So if I'm the owner of the subscription, unless there's a deny rule somewhere, I have owner over every resource in the entire subscription. And that works with contributor and reader as well. Beyond subscription in Azure, and subscriptions in Azure are the functional equivalent of accounts in Amazon, Azure has a construct called management groups that lets me manage multiple subscriptions together in a single plane, because a lot of enterprises will have multiple subscriptions, so that simplifies it. The other thing you should understand is your identity provider and MFA. For those of you in Azure, you're probably using Azure Active Directory. It's got MFA available. It's pretty easy to turn on. Most of my customers on AWS are working with Okta or Duo to provide additional authentication protection and MFA into their accounts and tying into Amazon LDAP. And then finally, you should understand encryption and monitoring for things like penetration and any kind of various intrusions. There are services that can provide additional security and do some of that monitoring for you. See, we have a couple of questions here. When we talk about the responsibility matrix, can any most of the cloud contractors be contracted to support what would normally be considered the user's responsibility? And that's from Thomas Hart. There are places, and I hate to give a lame consultant answer, like it depends. Typically, you do that by moving up the stack. So you would move into a platform as a service offering, and there'll be more security as part of that platform offering. Whereas if you're using infrastructure as a service, you'll be responsible for more of it. There are other places where you can buy additional security services. But yeah, that is something I'd consider to be a benefit of the cloud. And then if you use containers to deploy to multiple cloud environments, do you still need to be concerned with the native security settings of each cloud, or can you rely on the security of each container? That was a good question, and the answer is absolutely you have to worry about the security settings for each cloud. And this is one of the things that makes multi-cloud so challenging. So one of the reasons why people really like containers is it makes it easy to deploy across multiple clouds. But if you think about your cloud control plane, think about like anybody who's in there has access to your data center if you had a real physical data center. or even like your VMware vCenter. So yeah, you have to have that locked down. Even if you're using containers, you need to manage network security. So yeah, there's a lot there. And then let me take one more before we move on. Data exfiltration is one of our major concerns. Most solutions I see I have identified are well beyond our budgetary limit, small business. Can you touch on exfiltration techniques? It's really hard for a small business. I know a lot of folks, I'm a Microsoft MVP, and I see a lot of communications about it. Microsoft has some pretty good solutions in the Office 365 space. Unfortunately, they're pretty expensive. We'll talk a little bit more about this later because I want to address that because it does tie into things like GDPR and such. All right, let's dive into talking about protecting data. And this is going to lean heavily towards database data because I lean heavily towards database data as well. A lot of data breaches. I picked this from a slide I did in a presentation I did a few years ago, but it's only gotten worse, and it always gets worse. Attacks are ever present. You know, we have a nation state who's probably pretty mad at us right now because we sanction them a lot. That has a lot of hackers. And honestly, a lot of organizations just don't do security well. We see a lot of folks don't put the time and effort into their technology that they probably should, and they're at risk, right? Or worse, you have smaller organizations that kind of try to manage, get in over their heads on what they can manage, right? It's when you're a small organization, it's hard to hire a lot of IT professionals. You don't necessarily have the budget to hire the staff you might need to manage and maintain your resources. And it's hard. Like we talked about, you know, people working from home and data exfiltration. And a lot of times you'll hear people talk about simple solutions like, and I know I said turn on MFA, or patching, right? And theoretically patching is easy and turning on MFA is easy. But you have, a lot of times if you're working with third-party software vendors, you have to get approval from them to apply patches. Especially if you're a small organization, you may depend on the third party for approval. But remember, like what I said earlier, start out with the small things and move into the big things. And the more you can do to separate your network and minimize access to critical data, the better off you'll be. Data security is everyone's responsibility. It's not just the responsibility of the DBA. It's not just the responsibility of the system admin or the chief information security officer. It's also part of the business analyst who's connecting to, you know, running Tableau or Power BI reports. You know, if you're a business user and you're like, why am I seeing all the social security data unmasked and I don't need this data to do my job? Security and privacy are always part of everyone's job, and I mean that sincerely. Everyone in the company, that's your job. Like it's Amazon says security is job zero, like it's the most important thing, and they like to count from zero because computer nerds. But yeah, it is definitely, it's way more visible now. I think there's more budget going to security, but it's not nearly as sexy as some other topics. I know back when we had conferences, and I'm actually going to a conference next week in London, so I'm a little excited about that. But whenever I do a security talk at a conference, I have fewer people than if I'm doing a talk on, say, performance or optimizing things. But it is a really important topic. Stephen mentioned this in the last session to an extent, and this is something I really like to touch on. Always ask, why are you collecting and storing this data? Really about anything. And this has multiple ramifications. If you're storing data, you're responsible for it. You have to store it on disk. You have to pay for storage. You have to back it up. You have to manage it. In the case of database systems, you know, if your database is bigger, you might end up, depending on the nature of how you're querying your data, you might need bigger virtual machines in front of your database servers. That can cost more. So if you can reduce the amount of data you're collecting, or you don't have a business need to collect it, or you can delete the data after 6 or 7 months. That's something that's really important. There are other times where you can't. I worked for a medical device company that got into legal trouble, and we had to keep all of our emails forever because the federal government said so. So what that meant was we had to buy a lot of storage to keep emails. It was early days before the cloud. But let's dive into some technology options you have for protecting your data. So the first thing I want to talk about, and I know our sponsor has some solutions in this space, and Microsoft has a solution in this space. Cataloging and knowing your data is really important. I'll have another slide where I talk about data catalogs, but a lot of organizations don't know what data they have. And this, when we talk about things like GDPR, where you can get fined if you have a data breach, GDPR, you'll get fined way less if you can tell the auditors, yes, we had a data breach. It was this specific set of 20 customers. This was their location, and this was the exact data that got breached. Cataloging, I feel like whenever I talk about data security or governance or cloud cost management or any of these topics, I always end up talking about governance a lot. And I've worked with a lot of smaller or even medium-sized organizations and even enterprises. And when you're in an enterprise, this is absolutely crazy because enterprises have so much data. It's hard to fathom. And there are so many teams. I'd love to see a well-organized data. And I've worked for one. They happen to be a cloud provider where they had a pretty good handle on what all their data was. But having some kind of data catalog solution in place to manage this is really important. So it's important to know what data your application stores so you can protect that data. Your developers and your third-party vendors probably aren't thinking about this. So to me, one of the bigger challenges you have is third-party software, right? If you're buying software from a third-party vendor, unless you're kind of reverse engineering their database, which is something I always used to like to do as a DBA, you don't necessarily know what they're collecting. So if you're not going to do that reverse engineering process, when you're analyzing the vendors you're going to work with or whose packages you're going to buy, that's where you want to think about how to catalog this. And security is more important than performance. I know performance is cool, and I enjoy giving those talks, and it's really awesome to make a query go from like 20 minutes to 5 seconds. But if the data is breached, it doesn't really matter how fast the query runs, does it? So in terms of protecting your data, use multi-factor authentication everywhere you can. I know I've probably said this 10 times already in this session. One of the things I like about newer platforms and newer authentication methods is they almost all support MFA. The Azure MFA solutions are really elegant. We use it kind of across the board. Okta and Duo with AWS are also really slick. I use them in a number of different customer environments. One of the fun things about being a consultant is you get to have like 12 different authentication apps on your phone. But number one, if you talk to any security expert, easy thing you can do to do it. Separation of duties is important. I think this is one that's really hard for small organizations because you can't, you just don't have enough people to separate out duties. My favorite story was as a consultant, we had a pretty small client and they wanted us to encrypt some data in a database so that like one person couldn't see the other person's salary. And I thought that was a really funny separation of duties story. But if you can do that, do it. Like sysadmins maybe shouldn't have access to the databases and vice versa. The next one's really important. Don't use your regular account for admin tasks. And it's going to tie into the next point I'm going to make. At DCAC, and we're not that big, I'm Joey at DCAC.com, and that's my normal user account. My admin account is adminJD. And what I do with that is that means if I'm doing any sort of administrator task, my normal account is not administrator, and our both domain and our databases and our Azure control plane. So that means I'm not logging in as admin JD nearly as frequently. I'm only logging in when I have to do a task. You should also audit admin access regularly so you can see if there's any unusual admin access. There are solutions that allow, and they're painful, and maybe I should mention this, anything that usually increases security makes life harder somewhere else. So just think about security in kind of a normal world. If you're going into if you're flying on a plane, you have to go through security, and that's painful. But theoretically, the plane's more secure because you've gone through a metal detector and been checked for stuff. Any security control you add is going to add overhead to your processes, but it's something you have to do. It's the cost of doing business. But auditing that admin access means you can by limiting admin access, it makes it easier for you to audit, and you get that other benefit I was telling you about, less risk to credential surfing. So less risk for somebody grabbing an admin credential and moving across laterally. There is a concept in some security management systems called just-in-time access, where you actually have to request admin access to a group to log into something. I know when I worked at a cloud provider, we had to do that. And this is what I mean by limit access to production. So you don't necessarily have to, secure shell in or RDP into your production servers. You should have better access controls around that and more automated ways of doing that, especially for systems that are public facing, because you don't want to leave those endpoints publicly available. The second to last one cropped up again this week. You shouldn't be using production data in development environments, especially if you have any sort of personally identifiable information in your data. We had a customer this week who wanted, and it's funny, they have a lot of compliance controls, but they wanted us to build something for them to enable their developers to download or to restore copies of the production database into their laptops. And my coworker and I, about freaked out when they first asked about it. We're like, we can facilitate that, but why are you doing that? And they're kind of a heavily audited group. So we were like, and your auditors are okay with that, but they want all these other controls in place. And they're like, yeah. It's like, did not like that. Don't do that one. That's not a best practice. And use common sense. Think about things. And this really applies. Security starts at application development. If you're not developing, it's really hard to bolt on security. You kind of have to think about security from the beginning of your application development process. So we have a couple other questions. For data encryption, should you encrypt data at the drive level, the database level, the field level, or both? That's the best kind of question because I have it answered on another slide. We'll get there in a second. And I had a question of, do they run a background checks that work with cloud security? The cloud vendors all do run background checks on anybody who touches anything remotely related to the cloud. I've been through that process, and I barely touch the cloud. So, yeah. And I thought I saw a question about what password manager do I recommend. A lot of my colleagues use LastPass. I love 1Password. It's my favorite, one of my favorite pieces of software that I've used. So this is one of my worst client stories. I was doing a performance analysis on a database server for this client. They had a job that was called something SSN job, and I don't remember, but I was like, I have to go look and see what this does. Well, I looked and saw what it does, and it pulled back like 400,000 unencrypted records with the social security numbers and all the personally identifiable, all the data you need to steal somebody's identity. So that was pretty bad in and of itself. So it was like, ooh, this is bad. Then I did a little bit deeper analysis of the server, and both SQL Server and Oracle have this concept of link servers where you can make a remote call to another Oracle or SQL server. And typically you'd configure this to impersonate the credentials of the user that was making the call. So if Joey was calling from server A to server B, you'd use Joey's credentials. Well, in this case, they used SA, which is the system admin account on SQL Server, root, basically. So it had full control over the server. So if you passed a query in that referenced that server, you now were a system admin. You could basically drop all the databases if you wanted to. Finally, on the target server, they had domain users had a pretty high level of access. So domain users could effectively become SA on another server. So you just built your own security breach. And this was one where I had to call our lawyers to talk to them to say what was the right way to tell them how bad this was. Because, this is about the worst thing I've ever seen in terms of security. So when you connect things, and I can tell you probably how easily this worked. They set up the link server because they wanted to make a call to another table on another server. Whoever the DBA was didn't really understand how link server authentication worked, and they got some security errors, probably made it SA, and then nobody noticed that domain users had access to a server that had a connection back as a link server. Once again, it's like probably not anybody's fault, just a bunch of things that work together to leave stuff wide open. So what does the cloud do for you? It provides encryption at rest, and this ties back to that question. I kind of deferred until this slide. Encryption at rest is really good for a couple of things, but mostly checking audit boxes. I don't really feel like it secures your data because, like, if you have a database that's encrypted at rest, anybody who has access to the database itself can still, say, connect Excel to it, make an ODBC call, and return all of the data. But it does lock in place encryption at rest. It does encrypt your backups in a lot of cases by default. The clouds also have security centers that will help you identify best practices and tell you things you're doing wrong or possibly doing wrong. Those are really nifty because, it can be like an extra set of hands to do productivity and give you kind of expert advice, even though sometimes the advice is a little bit without context. But if you're a smaller organization, it can give you a much firmer security footprint. PaaS services, like platform as a service offerings, like database as a service or web server as a service, they offer additional layers of security over what you may have had on-prem. You have built-in web application firewalls that protect against things like SQL injection. You have additional firewalls or security monitoring that you can maybe enable as a cost option. But those are definitely things that are benefits. And even if you're running infrastructure as a service VMs, there's kind of solutions in place there. To me, this is one of the bigger ones. It's much easier to build network isolation. So you want to make sure your database servers can only talk to your application servers, and you want to split everything out. And this is where I talk about the cloud getting hard or security being hard. But it makes it much easier to build a pretty hardened network than it would be on-prem, where you'd have to have a lot of pretty expensive gear in order to do that, and expertise, more importantly. So having that expertise and those solutions in place, to me, that's a really cool thing. So it gives smaller organizations. I know I've had a couple of questions from some folks who work for really small businesses. You can have highly secure network environments without having to hire a Cisco engineer. Also, they offer tools like data catalogs that can go out and assess all your data and interact. So there's a lot of services, and this is where, to me, this is the curse and the benefit of the cloud. They're constantly delivering new services at the pace of software, so it's really hard to keep up with what's new, but there's a lot of good stuff out there. So if you can keep up with it, or at least keep up with the stuff in your space, there's definitely beneficial servers. So what is a catalog and why does it matter? Do you know where all of your data is, or who has access to what databases? Do you have a centralized place to share data sets from your reporting? Do you even know what your data is? A data catalog is going to connect to all of your systems, use some, I hate to use the term AI, but it's going to make some inferences about your data based on context, and then bring all that back into a central location that you can report about. These solutions frequently aren't cheap, or they can be part of your backup solution. I know our sponsor, Rubrik, of this session has a pretty nice solution. I wrote a white paper on it. It kind of hooks into your backup to do that. But there's a lot of cool stuff. And when I talk about knowing what your data is, that is really helpful in terms of being able to, if you have a breach, know exactly what was breached and how it was breached and what data got out, or who potentially had access to it. It just narrows down your scope. Beyond this, having a data catalog makes it a lot easier to build things like business intelligence reporting. And it's not the most interesting topic, but to me, it's one of the best things you can do in terms of both security and improving the productivity of your data and your organization. So like I say, let's talk about encryption. I'm paid to be a broken record, but encryption at rest isn't real data protection because anybody who has access to the database has access to the data. What encryption at rest does, it encrypts any files with an encryption key, and it also typically will encrypt volumes. So like your drives will also be encrypted. We do this, this kind of goes back, this goes all the way back to Sarbanes-Oxley, but the reason why we encrypt at rest is so that nobody could like take a drive out of a server and restore a database or stop a service and copy a database file or copy a file. Those files would be useless without the encryption key. So it does a little bit, but in a cloud world where like hardly anyone has physical access to the data, it's far less important. But it's easy, so why not do it? So if you really need to protect personal identifiable information or any sort of privacy information, it needs to be stored encrypted, and that means you have to store it in the database. So depending on what database you're using, this can be really hard or only kind of hard. SQL Server and Oracle do this really well, but it's still, even with SQL Server and Oracle, you have to make changes to your application code because effectively your application now has to have a key in the application to encrypt and decrypt the data. And that's really the real secret sauce of how database encryption should work. The key should be outside of the database engine so that the database administrator and the system administrator who would also have access don't have the ability to see unencrypted data. So code changes can be hard, but newer database features make this easier. The other thing to note, and this is one of the places where I think encryption at rest is really useful, is typically when you enable encryption at rest in a database, your backups are in turn encrypted. The other thing you should do is make sure your backups are stored online. This kind of ties into ransomware and modern things, but you want to have some kind of immutable storage, and I'm sure this will be a nice tee-off for Rubrik, but you don't want anything to be able to overwrite backups. And by the way, test your restores because backups are only as good as your restores. One of the other lessons learned that came out of today's experiment with the deleted VM was it's really important to do DR testing. This was something I had another customer who didn't delete their VM, but we did a DR test where you kind of had to do the same thing to fix things in the DR test. And we got our restore time down to like 20 minutes. So they shouldn't have been down for 4 hours. So it's important to test your backups and restores to make sure your backups are good, but it also gets you better at doing them, and maybe you can script more things and automate stuff. You are the last line of defense for your data. As an administrator, or you're responsible, or even a developer, you can be kind of responsible for your data. You want to protect your backups. Grant access very carefully. Don't over-grant access. It's all right if people get errors the first time. You want to minimize the permissions that they need. Be smart about how you grant that access. Have a catalog of your data. You really want to understand what data you're storing and why you have it. Encrypt data wherever you can, especially sensitive data. Don't be scared to escalate issues to management or above your management. I remember one time I was working and this was when I had a full-time job. I was working somewhere and we had an unsecured wireless network, and I ended up having to call the vice president of security before I could get somebody to care. Don't be scared to escalate. If things are bad, it's important that people know about it. And then finally, protect your data. And what does that mean? Restore, encrypt, secure. Remember, do the basics right, and then worry about moving to more advanced topics. And with that, David, do we have any questions that I didn't answer yet?
We certainly do. And I don't know where that echo came from. Sorry about that. Okay, let's get right to the questions. Taking them from the top. First question comes from S. Lord. If you use containers to deploy to multiple cloud environments, do you still need to be concerned with the native security settings of each cloud, or can you rely on the security of the container?
I think I touched on that, but I'll just rehash it. Yeah, you do, because remember, your containers don't run in isolation. Somebody's got to access there's access controls in each cloud. There's networking, all that stuff. So yeah, for sure, you need to understand at least the networking and the control plane security.
Okay. Here's a question from Gordon. What is the minimum test set needed to verify your system is secure?
If I knew that, I got to be honest, I wouldn't be in this presentation right now. I'd be sitting on top of my pile of money. I'd be selling you that piece of software. It's really complicated because there are a lot of layers to systems are complicated. There are layers everywhere. Is your data layer like? I think you can build constructs to say, is a specific system secure, right? Like if I have this specific kind of database server, are all the best security practices in place? And even that's hard because then you have to look at like all the data and see if there's any PII. I will say the security scores that the cloud give you is a pretty good assessment. It's not perfect by any means, but it does get you on that right track.
Okay. Here's a question from Roland. What is something that I must do when implementing Office 365 using my Windows AD structure to make that setup as secure as possible?
So to tie back to the thing I kept talking about is if you're on E3 O365, you have P1 Azure Active Directory because that's how you're authenticating against Office 365, and you can enable multi-factor authentication for all your users. That's probably the biggest thing in terms of security you can do there. There are a number of other security controls, and I'd recommend looking up some docs around hardening Office 365 security. But I think that's MFA is probably the biggest you can do. There are, I will say, for those of you there was another question about data exfiltration earlier. There are some really good controls around some of that stuff, but it is typically in the highest tier. And I think some of those things are even add-ons to the tier, and they're not cheap.
Okay. Last question is a follow-up from Gordon. He's wondering if it's common for organizations to run background checks on employees that work with cloud security.
Yeah, I mean, I went through that process at one of the cloud vendors I worked for as a consultant. I work with a lot of different customers, and it's not 100% of the time, but I've definitely had to get background checked, multiple times. It's not uncommon.
Okay. Well, that's all the questions we have. So thanks again for a great presentation and answering those questions, Joey.
Thanks, David.
All right, now I'm going to pass it over to Victoria for some closing announcements and the giveaway of our HP 15.6-inch touchscreen laptop. Victoria?
Thank you so much, David. I really appreciate it. Hi, everyone. My name is Victoria Waba, and I really want to thank you all for joining us today. A few closing announcements before you depart today. As you leave, you will be asked to take a short survey with your opinions of this event. Please share those honest opinions. Our editors read every comment, and they help shape our future events. And speaking of future events, we really want to thank our sponsor, Rubrik. They're sponsoring this event because they believe in this community and want to support events like these. So please show your support and appreciation by downloading their resources and visiting their site and contacting them for a demo. It's through their underwriting of these events that we can bring more summits in the future. I also want to mention that they have provided a link to a demo in your audience console to the right, so please take a moment to check that out. So thank you to Rubrik. Thank you to our speakers, our fellow moderators,